Playing with numbers. In the previous classes, we have learnt about factors and multiples. Now we shall review these and also study some new properties, types of numbers, and how to find lowest common multiple, LCM, and highest common factor, HCF. We know that 5 into 3 is equal to 15. Mathematically, we can read it in two ways. The product of 5 and 3 is 15, or 15 is a multiple of 3 as well as of 5. On dividing 15 by 3, quotient is 5, or on dividing 15 by 5, quotient is 3. In other words, 3 and 5 are factors of 15. Thus, we arrive at definitions of factors and multiples. Factor. A factor of a number is an exact divisor of the number itself. In other words, the numbers that are multiplied to get a product are called the factors. For example, 1, 2, 3, 4, 6 and 12 are factors of 12. Properties of factor. Number 1 is a factor of every number, and every number is a factor of itself. For example, factors of 4 are 1, 2, 4. Factors of 6 are 1, 2, 3, 6. Factors of 8 are 1, 2, 4, 8. Factors of 9 are 1, 3, 9. Every factor of a number is less than or equal to the number. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. Out of these numbers, 12 itself is largest factor of 12, and all other factors are less than 12. Every factor of a number is an exact divisor of that number. For example, the factors of 16 are 1, 2, 4, 8, and 16. Each factor of 16 exactly divides 16. Number of factors of a given number are finite, since every factor of a number is less than or equal to the number, property 2. Therefore, number of factors of a given number are finite. Example 1. Write all factors of 24, 32, 30. Solution 1. The given number is 24. Since 1 is a factor of every number and every number is a factor of itself, therefore 1 and 24 are its factors. If we divide 24 by 2, the quotient is 12 and remainder is 0. Therefore, 2 and 12 are also its factors. If we divide 24 by 3, the quotient is 8 and remainder is 0. Hence, 3 and 8 are also the factors of 24. 24 is also exactly divisible by 4 and gives the quotient 6. So, 4 and 6 are also factors of 24. The number 24 is not divisible by 5. Next number is 6, which is already mentioned as factor of 24. Listing all the factors of 24, we get 1, 2, 3, 4, 6, 8, 12, and 24. The given number is 32. Clearly, 1 and 32 are factors of 32. 32 is exactly divisible by 2, 4, 8, 16. Hence, factors of 32 are 1, 2, 4, 8, 16, and 32. The given number is 30. Clearly, 1 and 30 are factors of 30. 2, 3, 5, 6, 10, and 15. Listing all the factors of 30, we get 1, 2, 3, 5, 6, 10, 15, 30. Example 2. The product of two numbers is 64. Their sum is 20. Find the numbers. Solution. The product of two numbers is 64. The required two numbers are factors of 64, such that their sum is 20. The factors of 64 are 1, 2, 4, 8, 16, 32, 64. 4 and 16 are two factors whose sum is 20 and product 64. Hence, two numbers are 4 and 16. Example 3. Without actual division, Show that 11 is a factor of 11,011. Solution. The given number is 11,011. 11,011 is equal to 11,000 plus 11, which is equal to 11 into 1,000 plus 11 into 1, which is equal to 11 into, within brackets, 1,000 plus 1, which is equal to 11 into 1001. This implies 11 is a factor of, within brackets, 11 into 1001. Therefore, 11 is a factor of 11,011. Multiple. A multiple of a number is a number obtained by multiplying it by a natural number. For example, if we multiply 4 by 1, 2, 3, 4, 5, 6, and so on, we get 4, 8, 12, 16, 20, 24, which are all multiples of 4. Properties of multiples. Every number is a multiple of itself. For example, 5 is equal to 5 into 1. 6 is equal to 6 into 1. 8 is equal to 8 into 1. 12 is equal to 12 into 1, etc. Every multiple of a number is greater than or equal to that number. For example, the multiples of 6 are obtained by multiplying 6 by 1, 2, 3, 4, 5, and so on. Therefore, multiples of 6 are 6, 12, 18, 24, 30, and so on. The number of multiples of given number is infinite. The multiples of given number is obtained by multiplying the number with natural numbers, which are infinite. Hence, multiples of a given number are infinite. Example 1. Find the multiples of 7, which are greater than 21, but less than 84. Solution. To find multiples of 7, we multiply 7 by 1, 2, 3, 4, 5, 6, and so on. Since the multiples of 7 have to be greater than 21, therefore, 7 into 4 is equal to 28. 7 into 5 is equal to 35. 7 into 6 is equal to 42. 7 into 7 is equal to 49. 7 into 8 is equal to 56. 7 into 9 is equal to 63. 7 into 10 is equal to 70. 7 into 11 is equal to 77. 7 into 12 is equal to 84. The required multiples are 28, 35, 42, 49, 56, 63, 70 and 77. Example 2. Write the first 5 multiples of 19. Solution. We will get first 5 multiples of 19 on multiplying 19 by 1, 2, 3, 4 and 5. 19 into 1 is equal to 19. 19 into 2 is equal to 38. 19 into 3 is equal to 57. 19 into 4 is equal to 76. 19 into 5 is equal to 95. The first 5 multiples of 19 are 19, 38, 57, 76 and 95. Types of natural numbers. Even numbers. A natural number which is exactly divisible by 2 is called an even number. The numbers 2, 4, 6, 8, 10, 12 and so on are even numbers. There are infinite even numbers. The even numbers end in 0, 2, 4, 6, 8. Odd numbers. A natural number which is not exactly divisible by 2 is called an odd number. The numbers 1, 3, 5, 7, 9, 11 are odd numbers. There are infinite odd numbers. The odd numbers end in 1, 3, 5, 7, 9. Prime numbers. A natural number which is greater than 1 and whose only factors are 1 and the number itself is a prime number. The numbers 2, 3, 5, 7, 11, 13, 17 are prime numbers. There are infinite prime numbers. The number 2 is only prime number which is even. All other prime numbers are odd. Composite numbers. The numbers having more than 2 factors are called composite numbers. For example, Factors of 4 are 1, 2, 4. Factors of 6 are 1, 2, 3, 6. Factors of 8 are 1, 2, 4, 8. Factors of 9 are 1, 3, 9. Since 4, 6, 8 and 9 have more than 2 factors, hence they are composite numbers. Co-prime numbers, the two numbers which have no common factor other than 1, are called co-prime numbers. For example, the pairs of co-primes are 2, 3, 3, 4, 5, 7, 8, 9, etc. Any two prime numbers are always co-prime. Co-prime numbers need not be both prime numbers. For example, 9, 10 are co-primes, but both 9, 10 are not prime number. Perfect numbers. If the sum of all the factors of a number is twice the number, then the number is called a perfect number. For example, the factors of 6 are 1, 2, 3, 6. Their sum, 1 plus 2 plus 3 plus 6, is equal to 12, is 2 times 6. Hence, 6 is a perfect number. The factors of 28 are 1, 2, 4, 7, 14 and 28. Their sum, 1 plus 2 plus 4 plus 7 plus 14 plus 28 is equal to 56, which is 2 times the given number 28. Hence, 28 is a perfect number. Twin primes. These are pairs of prime numbers which follow each other and differ by 2. For example, 3, 5, 5, 7, 11, 13, 17, 19, etc. Prime triplet. A set of 3 consecutive prime numbers differing by 2 is called a prime triplet. The only prime triplet is 3, 5, 7. Example 1. Write all prime numbers between 10 and 25. Solution. We have to find the numbers between 10 and 25 whose only factors are 1 and the number itself. Such numbers are 11, 13, 17, 19, 23. Example 2. Can a composite number be odd? If yes, write the smallest odd composite number. Solution. The smallest odd number which has more than 2 factors is 9. Its factors are 1, 3, 9. Hence, 9 is the smallest odd composite number. Example 3. Write all pairs of twin primes less than 20. Find whether 37 and 39 are twin primes or not. Solution. We have to find pairs of prime numbers which follow each other and differ by 2. The pairs of twin primes less than 20 are 3, 5, 5, 7, 11, 13, 17, 19. 37, 39 are not twin primes, as 39 is not a prime number. Properties of even and odd numbers. Type of number, operation, result. Even number, addition or subtraction with 1. Odd number, addition with even number, addition with odd number, multiply with even number, multiply with odd number, even number. Odd number, addition or subtraction with 1, even number, addition with odd number, even number, addition with even number, odd number, multiply with odd number, multiply with even number. Sieve of Eratosthenes. We can find prime numbers from 1 to 100 with an easier method. This method was given by Greek mathematician Eratosthenes in the 3rd century BC. List all the numbers from 2 to 100 as shown below. 1 is not a prime number. Step 1. Encircle 2. Cross out all the multiples of 2 other than 2 itself. Step 2. Next, uncrossed number is 3. Encircle 3 and cross out all the multiples of 3 other than 3 itself. Step 3. Next, uncrossed number is 5. Encircle 5 and cross out all the multiples of 5 other than 5 itself. Step 4. Continue this process till all the numbers in the list are either encircled or crossed out. All the encircled numbers are prime numbers. All the crossed out numbers are composite numbers. Thus, the prime numbers from 2 to 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23. 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Perhaps Eratosthenes made holes in the paper instead of crossing out the numbers. The paper must have looked like a sieve, hence the name. Tests for divisibility of numbers. In order to find whether a given number is divisible by another number, we generally perform actual division and see whether remainder is 0 or not. This procedure is very time-consuming and tedious. There are certain tests for divisibility of numbers, with which one can easily determine simply by examining the digits whether a given number is divisible by any of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Divisibility by 2. A number is divisible by 2 if its ones digit is 0, 2, 4, 6, or 8. For example, the numbers 1472, 564, 3286, 428, 740 are divisible by 2 since their units digit are 2, 4, 6, 8 and 0 respectively. Divisibility by 3. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, 7563, since sum of the digits 7 plus 5 plus 6 plus 3 is equal to 21 is divisible by 3. Hence, the number 7563 is divisible by 3. Divisibility by 4. A number is divisible by 4 if the number formed by the last two digits, that is, tens and ones places, is divisible by 4. For example, the numbers 2076, 728, 764 are divisible by 4, since their last two digits are divisible by 4. Divisibility by 5. A number is divisible by 5 if its ones digit is either 0 or 5. For example, 475, 6280, 345 are all divisible by 5 because their ones digit is 0 or 5. Divisibility by 6. A number is divisible by 6 if it is divisible by 2 and 3 both. For example, the number 43542 is divisible by 2 as its ones digit is 2. It is also divisible by 3 as sum of its digits 4 plus 3 plus 5 plus 4 plus 2 is equal to 18 is divisible by 3. Hence, 43542 is divisible by 6. Divisibility by 7. A number is divisible by 7 if the difference between twice the last digit and the number formed by rest of the digits is either 0 or a multiple of 7. For example, in the number 3675, the last digit is 5, as 367 minus, within brackets, 2 into 5 is equal to 357 is a multiple of 7. Hence, 3675 is divisible by 7. Divisibility by 8. A number is divisible by 8 if the number formed by its last three digits is divisible by 8. For example, in 6328, the number formed by last three digits is 328, which is divisible by 8. So the number 6328 is divisible by 8. Divisibility by 9. A number is divisible by 9 if the sum of its digits is divisible by 9. For example, in 36054, the sum of the digits 3 plus 6 plus 0 plus 5 plus 4 is equal to 18 is divisible by 9. Hence, 36054 is also divisible by 9. Divisibility by 10. A number is divisible by 10 if the digit at one's place of the number is 0. For example, the numbers 790, 84680 are divisible by 10 because their ones digit is 0. Divisibility by 11. A number is divisible by 11 if the difference between the sum of digits at odd places and the sum of the digits at even places starting from ones place is either 0 or a multiple of 11. For example, in number 61809, the sum of the digits at odd places is 9 plus 8 plus 6, which is equal to 23. The sum of the digits at even places is 0 plus 1, which is equal to 1. Their difference is 23 minus 1, which is equal to 22, which is a multiple of 11. Hence, 61809 is divisible by 11. Example 1. Which of the following numbers are divisible by 2? 3250, 9628, 7435, 5786. Solution. A number is divisible by 2 if its ones digit is 0, 2, 4, 6 or 8. 3250 is divisible by 2 as its ones digit is 0. 9628 is divisible by 2 as its ones digit is 8. 7435 is not divisible by 2 as its ones digit is 5. 5786 is divisible by 2 as its ones digit is 6. Example 2. Find out by divisibility rules which of the following are divisible by 3. 5412, 832, 5463, 519. Solution. A number is divisible by 3 if the sum of its digits is exactly divisible by 3. Since the sum of the digits of 5412, 5 plus 4 plus 1 plus 2 is equal to 12 is divisible by 3. Hence, 5412 is divisible by 3. Since the sum of the digits of 832, 8 plus 3 plus 2 is equal to 13, is not divisible by 3. Hence, 832 is not divisible by 3. Since the sum of the digits of 5463, 5 plus 4 plus 6 plus 3 is equal to 18, is divisible by 3. Hence, 5463 is also divisible by 3. Since the sum of the digits of 519, 5 plus 1 plus 9 is equal to 15, is divisible by 3. Hence, 519 is divisible by 3. Properties of divisibility. If a number is divisible by another number, it must be divisible by each of the factor of that number. Example, we know that 36 is divisible by 12. The factors of 12 are 1, 2, 3, 4, 6. 12. 36 is divisible by each one of the factors 1, 2, 3, 4, 6. 12. If a number is divisible by each of the 2 or more than 2 co-prime numbers, it must be divisible by their product. Example, the number 80 is divisible by 4 and 5, as 4 and 5 are co-prime numbers. So, 80 must be divisible by 4 into 5, which is equal to 20, which is true. If two given numbers are divisible by a number, then their sum is also divisible by that number. Example, the numbers 16 and 20 are both divisible by 4. The number 16 plus 20 is equal to 36 is also divisible by 4. If two given numbers are divisible by a number, then their difference is also divisible by that number. Example, the numbers 15 and 40 are both divisible by 5. Their difference, 40 minus 15 is equal to 25, is also divisible by 5. To find prime numbers between 100 and 200, if the given number is divisible by any prime number less than 15, that is 2, 3, 5, 7, 11 and 13, then it is not prime. Otherwise, it is prime. Example 1. Which of the following numbers are prime numbers? 117, 143. Solution. On testing the divisibility by each of the prime numbers 2, 3, 5, 7, 11, 13, taking one by one, we find that 117 is divisible by 3. Therefore, 117 is not a prime number. 143 is divisible by 11, so it is not a prime number. To find prime numbers between 100 and 400. If the given number between 100 and 400 is divisible by any prime number less than 20, that is 2, 3, 5, 7, 11, 13, 17 and 19, then it is not prime. Otherwise, it is prime. Example 1. Which of the following numbers are prime numbers? 357, 277. Solution. We test the divisibility of 357 by each one of the prime numbers 2, 3, 5, 7, 11, 13, 17 and 19. The number 357 is divisible by 3. Therefore, 357 is not a prime number. 277 is not divisible by any of the prime numbers 2, 3, 5, 7, 11, 13, 17 and 19. So it is a prime number. Common factors and common multiples. We have learnt about factors and multiples of a number. Let us now observe the factors of some numbers taken in pairs. Factors of 4 are 1, 2, 4. Factors of 6 are 1, 2, 3, 6. The numbers 1 and 2 are the factors of both 4 and 6. They are called common factors of 4 and 6. Example 1. What are common factors of 12 and 18? Solution. The factors of 12 are 1, 2, 3, 4, 6, 12. The factors of 18 are 1, 2, 3, 6, 9, 18. Clearly, 1, 2, 3, 6 are the common factors of 12 and 18. Common multiples. Let us consider two numbers 4 and 6 and find their multiples. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, and so on. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. We observe that 12, 24, 36 are multiples of both 4 and 6. These are called